Exercise 11.07 on integration, A-Level Pure Maths, Year 2. Question 1. Use the formula for sine A plus B with A as 3x and B equals to x to show that 2 sine x cos 3x can be written as sine kx minus sine px, where k and p are positive integers. B. Hence or otherwise, find the integral of 2 sine x cos 3x dx. C. Hence, find the exact value of the integral of 2 sine x cos 3x dx between the limits of pi over 2 and 5 pi over 6. So we are going to start with this formula, replacing a with 3x and b with x. So we have sine bracket 3x plus x. If I expand that, I'm going to get sine 3x cos x plus sine x cos 3x. I'll do the same expansion, but this time with the plus replaced with minus. So I'm going to get sine bracket 3x minus x is equals to sine 3x cos x minus sine x cos 3x. But we can see that 3x plus x is 4x and 3x minus x is 2x. So we can rewrite these two equations as follows. Sine 3x cos x plus sine x cos 3x equals to sine 4x. Similarly, I can write this equation as sine 3x cos x minus sine x cos 3x equals to sine 2x. If I label the first equation as equation 1, second one as equation 2, I can now subtract equation 2 from equation 1. If I do that, I'm going to put my minus sign here and draw a straight line over here. And then do my subtraction. And you can see immediately that this minus that will give me 0. And then this minus minus means that I'm going to add them. So then I end up with 2 sine x cos 3x is equals to sine 4x minus sine 2x. So now if I compare this expression here with that, I can conclude that k is equals to 4 and p is equals to 2. So this is the values of p and k. So that was A. Now B. I've got the integral of 2 x cos 3x dx. Since 2 sine x cos 3x is equal to sine 4x minus sine x, we can say that this integration here will be the same as the integration of sine 4x minus sine 2x. All of that with respect to x. And now we know this can easily be integrated. If we integrate sine, we get minus cos. So it means this is equal to minus a quarter cos 4x plus half cos 2x, and then your integration constant c, because a negative and a negative gives you positive. Writing this nicely, you're going to get half cos 2x minus a quarter cos 4x plus c. And this is the required integration. You can now move on to c. Hence, find the exact value of the integral of 2 sine x cos 3x dx between the limits of pi over 2 and 5 pi over 6. So, the integral of 2 sine x cos 3x dx from pi on 2 to 5 pi on 6. We have integrated this already in B. So we are going to use that. So we're going to use this integral here without the integration constant. So we have half cos 2x minus a quarter cos 4x between those two limits, pi over 2 and 5 pi on 6. So we are now going to evaluate this by substituting the limits. So we have half cos 2 times 5 pi on 6 minus a quarter cos 4 times 5 pi on 6. All of that minus half cos 2 times pi on 2 minus a quarter cos 4 times pi on 2. If we evaluate that, we are going to get half cos 5 pi on 3 minus a quarter cos 10 pi on 3. All of that minus bracket half cos pi minus a quarter cos 2 pi. So if we evaluate that, we're going to get 1 over 4 for this part plus 1 over 8 for this one plus half for that, and finally plus 1 over 4. So this will give us 9 over 8, which is equal to 1 over 8. And that is the answer for part C. Question 2. Use the substitution x equals to sine theta to find the exact value of this integration here. So 1 over 1 minus x squared, all of that to the power 3 over 2 with respect to x between the limits of 0 and half. So first of all, we have x is equals to sine theta. This implies that x squared is equals to sine squared theta. Dx is equals to cos theta d theta. So the next thing to do is rewrite this in terms of theta. So I have 1 minus x squared, all of that raised to the power 3 on 2 will be equals to 1 minus sine squared theta, all of that raised to the power 3 on 2, because we know that x is equals to sine theta. Now, let's go ahead and simplify this. So I'm going to get cos squared theta, all of that raised to the power 3 on 2, because I've used trig identities to turn 1 minus sine squared theta to cos squared theta. If I simplify that, I'm going to get cos cube theta. The next thing to do is rewrite that in terms of theta. The limits 0 and half are in terms of x. We have to find the theta equivalent of 0 and half. So I'll draw a small table here and then put x here and theta over here. So now, when x is 0, which is for this case, 0 is equals to sine theta, which implies that theta is equals to sine inverse of 0, which is equals to 0. So when x is 0, theta is equals to 0 as well. And then I have half over here. So when x is equals to half, or half equals to sine theta, this implies that theta is equals to sine inverse of half, which is equals to pi over 6. So I can write pi over 6 over here. So then we are now ready to rewrite this in terms of theta. So integral of 1 over 1 minus x squared all to the power 3 over 2 dx from 0 to half can now be written as integral of 1 over cos cube theta, because we said all that is equal to cos cube theta, and then times dx. dx will be cos theta d theta, so that will be cos theta d theta. And the new limits will be 0 and pi over 6. So that will simplify to the integral of 1 over cos squared theta d theta, because one of these cos cube theta will be cancelled by cos theta, and our limits are 0 and pi on 6. 1 over cos squared theta is sec squared theta. So this whole thing becomes integral of sec squared theta d theta from 0 pi on 6. If we integrate sec squared theta, we're going to get tan theta. Therefore, I have tan theta between the limits of 0 and pi on 6. If we evaluate that, we're going to get tan pi on 6 minus tan 0. But tan pi on 6 is root 3 on 2, and tan 0 is 0. And so our final answer is root 3 on 2. And that is the answer for question 2. Question 3. Using the substitution u squared equals to 2x minus 1, or otherwise, find the exact value of this integral 3x over square root of 2x minus 1 with respect to x between the limits of 1 and 5. So u squared is equals to 2x minus 1. I'm going to use implicit differentiation to differentiate this one here. So if I do that, I'm going to get 2u du equals to 2 dx. If I divide both sides of the equation by 2, I'm going to get u du equals to dx. Then I'm going to rearrange this equation here and make x the subject. So if I do that, I'm going to get x is equals to half brackets u squared plus 1. But I will need 3x, so I'll multiply this by 3. And if I do that, I'm going to get 3x equals to 3 over 2 brackets u squared plus 1. But I need to change all that to u. So it means I need to find the u equivalent of the limits 1 and 5. So I'll draw my little table again, and then I've got x and u. So we have 1 and 5. So when x is 1, I'll get 2 times 1 minus 1, that's 1, and the square root of 1 is 1. So when x is 1, u is 1 as well. When x is 5, I have 2 times 5, 10. 10 minus 1 is 9. The square root of 9 is 3. And so that will be 3 over here. So I can now do my substitution fully to change all that to u. So then I'll have integral of 3x over square root of 2x minus 1 dx from 1 to 5 can be written as the integral of 3 over 2 brackets u squared plus 1. That is for the 3x all over square root of u squared, because 2x minus 1 is equal to u. And then we know dx is equal to u du. So multiply that by u du. We can now simplify that, and we are going to get the integral of 3 on 2 u squared plus 1, all of that over u, because the square root of u squared is u, times u du. And this further simplifies to 3 over 2 integral of u squared plus 1 du, because this u will cancel that u and I end up with this one. And our limits have changed from 1 to 3. So you have 1, 3 over there, 1, 3 over there, 1 and 3. So now we are going to integrate that, which is now very easy to do. So I'm going to get 3 over 2, 1/3 u cubed plus u between 1 and 3. I can now do my substitution. I have 3 over 2 square brackets 1/3 times 27, because 3 cubed is 27 plus 3 minus 1/3 plus 1. So now we have 3 over 2 brackets 12 minus 1/3. That will give you 3 over 2 times 10, 2/3. Simplifying will give you 3 over 2 times 32 over 3. 3 goes to 1, 3 goes to 1, 2 goes to 1, 2 goes to 16. And so our final answer is 16. And that is the answer required for question 3. And that brings us to the end of exercise 11.07. Thank you for watching. See you in the next video.